So, still working.
Are they online or just? Are they online or did you just?
They're online.
It was on TV last night. It was happening like that.
It's really crowded in here.
It's very tight on this road.
We'd like to get started. We welcome you here to this session this morning. I know it's kind of hard on the last day. Tired of being in the conference after a couple of days. This is the I-15 Pine Creek Climbing Lanes and ATMS ITS. My name is Troy Torgerson. I was the project manager for the project. Got a group of people here I'll introduce. So we're going to review our climbing lane project, which is north of Beaver on I-15. We had a climbing lane portion, which you see right here on the slide, went from 120.46 to about really 127. The 133.45 is how far the ATMS went, and on I-70 we had ATMS and went from 0 to 2.54. So we'll talk about some of those issues. The hopes of this session right here is to talk about some of the things that we learned from this project that can be used on future projects to avoid change orders and other issues of frustration. So I'm currently the regional project manager at Ridgefield. I've been with UDOT since 1998. I worked for another firm prior to that, and the father of 6 children. Greg Neff, who was supposed to be here from Ames, couldn't make it, so we have Brad Celerak. He works with Ames. He's down second from the right down there. Tyler Turner is the senior project manager for civil science at St. George. He's sitting right here. He has over 17 years of experience in the planning, design, and construction of a wide variety of projects throughout the West. Sonia Lutmanka. She is the principal investigator and owner of Desert West Environmental. She has 18 years of experience in cultural resource management, national environmental policy, and project management, and is a cultural resources contractor for the Pine Creek Truck Climbing Lanes ATMS project. Brett Anderson. He was the RE on the project, has a bachelor's degree in civil engineering from Utah State. He was a resident engineer on the project. He's a father of 6 children. Boyd Wheeler, on the end, is a senior engineer, bridge engineer with HGR Engineering, where he has worked for nearly 8 years. After 18 years working for UDOT, and when not involved in bridge projects, Boyd enjoys spending his time with his family, including his 2 grandchildren. We also have quite a few people from our region that worked on the project with Transtex, and Ryan back here, one of the field engineers, so we appreciate the support here today. So I'll pass out the rolls to the time when we're good. All right, let's get started.
You guys can't hear me. I apologize. I don't like to sit here and talk in the microphone, so I'm going to try to be heard. If you can't hear me, just raise a hand. I'll try to. Can't turn it up? Is that too loud? Okay. As far as what we want to try to cover here today, first we want to have kind of an overall project overview, where we'll talk about some of the characteristics of I-15 in this area. We'll talk about some of the project goals, and then we'll go through and show you kind of the finished product. Then we'll go into what Troy was talking about, some of the lessons learned and best practices in both the pre-construction and construction phases of the project. Again, as Troy mentioned before, probably the main goal of this presentation is to try to provide some suggestions for future projects similar to this one. We felt like some things went really well during both design and construction. And there's things that could definitely be bettered on future projects. So hopefully we can talk through, again, some things that should be considered on future projects. Project team, as we all know, a project of this magnitude takes several people to make it successful. This is with the people that are standing here today, and well as the ones listed there, a pretty good representative sample of those that were involved in the project. And overall, it was a pretty effective team, and we're happy with how it was delivered. So project overview, I think most of the people that I see here are probably familiar with where this project was, but for those that are not, it's located in Beaver County, just about 10 miles north of Beaver on I-15. As Troy mentioned, there was a fairly large ATMS component of this. The roadway construction was from here to here, about 8 miles, and then it continued north to I-70 to Wells Cove Ford. So most of the roadway reconstruction took place from there to there. The development of climbing lanes and other features associated with that, and then most of the project through that is the extension of the ATMS. We're tied into existing facilities. So the project overview, some of the characteristics that define this section. It's steep terrain. With grades up to 5 to 6%. It's a winding alignment. Again, most of you have seen it and understand the conditions there. Steep side slopes. There's areas where the grades off the shoulder are pretty significant, and probably one of the biggest reasons that this project is there is not only the amount of traffic but the trucks. 25% trucks. You see several in this picture. So that kind of gives you an idea of what the corridor is like. So project goals. Why was this project developed? Well, the trucks, there's a 2-lane facility at the time. If you've been through there and along several sections of I-15, and you get 2 lanes and you get those trucks trying to pass, it becomes pretty difficult. And this is one of the more significant areas, not only for climbing but weather related. And so one of the main goals obviously was to develop climbing lanes in both the northbound and southbound direction. At the same time, we wanted to seal the existing roadway surface. And then while we're doing the widening for the additional lanes, we also wanted to address the roadside hazards, where there's some substandard barrier, steep slopes, and things of that nature. Then we also, one of the items that we looked at during the design was the evaluation of operational improvements for chain-up areas. Again, this area sees a lot of weather-related delays, trucks, and so we wanted to see what types of things that we could implement with the project to help that. And then lastly, improve communication of the roadway conditions for both area maintenance and the TOC, and that was done through the ATMS improvements that Troy will discuss in a little while. So what I want to do now is just take you through just some pictures. We got some video clips that show you what the existing conditions were, and then the final product. A lot of people like to see pictures and see how it was done. This is a section at the south end of the project, kind of looking northwest. You can see it's just a 2-lane facility right there. This is what it looks like right now. So we developed a 3rd lane in the climbing direction here. And then this is an area here that we'll talk about further on in the presentation, where we had some excess material and use that as an area to place that. If there's anything that you guys would like to kind of point out on these slides, let me know. This is that same area, just looking southbound. That's existing, and that's that same area where that additional material was placed. You can see that the development of that 3rd lane. This area here, let's see, it's a little bit. All right. This area to the north, there was some cuts that, see it in the next picture, that there was some concerns about some shading. There were steep rock cuts, and we were able to address those to help with the freezing and the icing conditions that were on the roadway. This is near the summit, looking north. And that's what it looks like now. You can see there's fairly significant excavation in that area to develop. We developed an additional lane in both directions at this location. Some of the ATMS facilities that were constructed on the project. This is one of those cuts that I was describing earlier. You can see that in the morning hours, this area of the highway is going to be shaded. And working with maintenance during design, they expressed some concerns, and so we were able to lay that back during construction to help with that freezing. So I got to give credit to Ames on this. Jared Rico and their survey department, they have an aerial drone that they scan the project post-construction. So what we've got now is just kind of a video. This is starting at the south end of the project, going north, and it shows the finished product. Oops. That's the area of those cuts that I've shown you before. There's another, I believe this was the cut slope that was most challenging. Wasn't expected to be, but ended up being. And you can see throughout the length of the project, just a lot of cuts, fills. They actually did a pretty good job from what I saw as far as MOT and being able to kind of move that material without impacting traffic in a significant way. This is getting towards the top, the last few pictures that I showed. And this is just northbound. You can see the cut there on the right, that's the ATMS that we discussed earlier. Now this is a fairly, we'll talk about a fairly significant archaeological site that Sonia will discuss further on in the presentation. So that was northbound. So this is starting at the north end of the project and going south. The summit is coming up here. This one you can see the Bull Hollow Road crossing and the structure widening that Boyd will present on here in a few minutes. Again, some large cuts. This is the Bull Hollow Road structure here. It was widened on both sides. On the project, we widened to the outside. So this is the summit here. So is that shows I don't know, I got to give credit to Ames. I think they did a great job during construction. I think we're all pretty pleased. I know the region is, as far as the product that was provided. And anyways, hopefully that was useful for those of you. I look out in the audience and I see a lot of people that have been involved in this project from its initiation. So a lot of you probably had a chance to be involved or seen the final product. If you haven't, it looks really good. So what we'll do now is we'll move into some of those lessons learned and best practices, and we'll start with pre-construction. And I'll go first. I'll talk about roadway. One of the larger items that we dealt with during the pre-construction phase was maintenance of traffic. We knew that there was going to be some fairly significant construction activities, but we also have a lot of traffic and specifically trucks that we knew that we needed to maintain. One of the biggest limitations that we dealt with in relation to MOT was we felt like we needed to maintain 2 lanes of traffic in those climbing areas. As I mentioned before, if you've been on I-15 in a 2-lane section in a climbing area where those trucks try to pass and you get one that's going really slow, it can have a big impact. So we felt like we needed to have that as a requirement during construction. And I'll go through some of the things that we felt like needed to be done, and I think that both Brett and Brad during their time will talk about how well that worked or didn't work. Another one of the items when it comes to maintenance of the traffic that we felt really needed to be implemented on this was the use of temporary portable rumble strips, and there was details provided by the region that were included, as well as specification, and that talked a lot about how they would be implemented, when, and the use of highway patrol troopers to implement those. And I think that had evolved quite a bit prior to this project, and I think it still does. I know that at least some of the feedback that I've gotten back from construction is there's still some room for improvement, at least from the construction side. So hopefully that's something that we kind of take from this and continue to work towards. Probably the biggest thing on this is we had all these limitations, and we had to make sure that we kind of covered all our bases. We really didn't tell the contractor how to do construction, but we had to consider everything that they might do and make sure that it was covered as far as how we wanted traffic to be maintained. Part of that was the providing blasting plan. So there's some rock slopes along the project that we didn't really do a lot of geotechnical investigations, so we weren't sure how they would have to be excavated. So there was fairly extensive blasting limitations. One of that is we knew that we needed to work with some contractors, and we knew we'd provide a certain time it would take to only load the holes, and set the charge, and then clear off the road if there's anything. So actually that impact, when we ran through the calculations, again, if you're familiar with the area, the start of the project, Beaver's about 10-15 miles to the south. We had to go all the way back to Beaver and deal with those interchanges. That's how far we'd have to go back to start slowing down traffic to provide that gap in traffic that we need. Another big item, as I mentioned before, is use of highway patrol, off-duty officers. I think we're starting to use that more and more. Obviously, you can see it on the point. They were heavily involved in this project. One of the things to keep in mind, and we tried to do it on this, and I think that I understand there's still some confusion, is how those are paid for. There's use for them in the implementation of their traffic control, but then we also had them being required if the contractor chose to blast and how they were to be used. So just make sure when you go to implement those in your projects that you're clear on how they're to be paid. And probably the one thing, if I could maybe make a recommendation, is I mentioned right here that just the limitations for traffic control in the 555 were 3 pages. I'm sure there's projects that have some that are far greater, but probably the biggest thing to make sure that you do is ensure those limitations are practical. Consider the equipment the contractor is going to have to use to do the work, and make sure that those limitations can be implemented and the contractor can still get the work done. Environmental resource impacts. This was during the design phase. This was probably one of the items that we had to work through probably the most. I'm going to bring up a map that shows these resources, and so if you can see these these yellow areas, those are environmental sites. The green line is one. So these are polygons. So these are areas that we had to stay out of, as well as all these. Zoom in a little bit. There's a bunch of linear sites littered throughout that we couldn't impact. Our initial approach was, at the start of the design, was to impact these. We really felt that we wanted to flatten the slopes, make this corridor as safe as we could. And then throughout design, there were several things that came up that we felt like we needed to address that had an impact on the development of that plan that environmental folks were working on. So as we continue to kind of make those changes, we kind of reset their schedule. So where we got close to the end of the project, we knew we had a fixed delivery date. So what we had to do is we had to go back and actually rework a few things to eliminate some impacts that had the potential to delay the project. Let's switch back. So as I mentioned there, we were able to develop alternatives that allowed us to maintain the project delivery schedule. Some of those included steeper side slopes. Still constructed a safe corridor, flattened slopes out to the clear zone. But essentially what we ended up doing is rather than having that straight cross slope till it catches, we actually broke it at the clear zone. There's one location near the summit. This was on northbound. That line right there is probably a little bit hard to see, but that's environmental fence. There's a large site that I think Sonia will show you that we determined that we needed to stay out of. We had cut slopes that went right into it initially. So what we ended up doing was implementing a retaining barrier. I think this has probably been used before, but essentially just a jersey barrier that allowed us to pull that out just enough to where we didn't have that large cut slope. Fortunately, during construction, we were able to during the time of construction, we were actually able to get that site cleared, and we were able to work a change order that eliminated that barrier. But this was an approach that was implemented that allowed us to kind of move the project forward. Site balance when it comes to excavation. This was something that we considered pretty strongly. We had almost 478,000 yards of excavation and only needed 255,000 yards for embankment. Obviously, with that, there's a risk for higher costs if that material has to be exported. So we developed options for placement of excess material outside of planned improvements. This included in areas where we could actually flattening the slopes, and as well as some optional embankment placement areas. And probably the biggest thing to make sure that you do when you're looking at these things is making sure that they're environmentally clear. This is, I mentioned, when I was showing those quick photos before, I showed that one slope where it was fairly large. That wasn't needed for the roadway's sake. However, that was an area that we felt like the contractor, if you could get the material there, could place a large amount of material. If you can see it, there's a thin line right there. That represents what we needed for the roadway widening. But we were able to develop this plan and put it in the project that showed the contractor an optional area where they could place the material and told them how much. It wasn't required work, but it just provided the contractor optional areas to where, they knew when they were bidding it that at least they didn't have to haul it off if they didn't want to. They had options on site. Excavation, soil or rock. This is something that we looked at extensively during the design. I showed you some slopes earlier where obviously after construction you can tell it was rock. Obviously with this picture right here, pretty obvious that's rock. This right here is a picture of that slope that I mentioned earlier that was the most difficult cut you look at that right there and you probably never guess. So we made a determination during the pre-construction that we would not do any boreholes to try to determine where rock and soil are. Obviously, with that comes risk. When your contractor's not sure what he's got to bid, what we kind of did is we kind of put that risk on them. One thing we did do though is we used visual investigations, and we said, okay, this cut right here will be rock, and this cut will be soil, and whatever it was during construction, what it was. But again, there's risk associated with that. Seeing how it went and hearing how it went, one recommendation or consideration that could be made is to perform some boreholes to determine rippability, hardness, and those things that might be useful to the contractor during bidding. This is a little bit of a soapbox for me. When it comes to soft shoulders, a lot of people here are from Region 4, so you're familiar. This might be used outside the region, I'm not sure. But we've got a soft spot repair, several bid items in there to talk about, to show the contractor options during construction if they get into areas that are soft. Been involved in a few projects over the past year where during construction they get out where we're placing fill off the shoulder and they're getting some soft materials, and from what I'm understanding, these initial approaches aren't working in every condition. So I think that Cameron and I, we've had some conversations over the past few weeks. I think it's being looked at. In addition to, might make a recommendation is there might be some value in performing some additional geotechnical work during the pre-construction phase to try to determine if there are some of these areas and whether these solutions that we've already got in place will work, or if we need to consider something else. And lastly, just overall communication during pre-construction. I think there's some things that we did that went really well, and then there's some things that we probably could have done better looking back. With the project team, the size that we had, we did have project bi-weekly coordination meetings where we pulled everybody together and talked through all the disciplines, where we're at, what's going well, what's not. One thing that we probably could have done better during that is pulling up the project schedule and seeing where we're at, making sure that everybody's still on track. Another useful tool that I know that is used pretty heavily in Region 4, and I think others are starting to use it, that U-Plan. That map that I showed you a few minutes ago is really useful. They've put together a routine that takes the CAD files and puts it in an ArcMap format and then placed out here in U-Plan. If I zoom in close enough, you're able to see all the cut and fill slopes. You're able to see lane lines, pavement, and all that, and that's a useful tool. In my opinion, it allows all the disciplines to see where the design's at, what the impacts might be to their work, and just allows everybody to have access to a tool that they can kind of understand what the project, current design is. A lot of focus on this, but involvement in maintenance during the pre-construction phase. There's several things that we ran into during design that we knew there was a utility here or there. Nobody knew where it was. Maintenance was able to be involved and provide input. They're also able to provide some really good input as far as conditions of the road, things that we need to make sure that we identified. But that bottom bullet, we learned that after the project was constructed, that there was a couple of things that they expressed during the design phase that they felt weren't addressed during construction. So probably the biggest thing is just to follow through on that. Make sure that what you're doing and implementing in that design is what maintenance is after as well, and you're addressing their concerns. And then, as I mentioned before, this coordination of impacts, environmental resources, that had the potential. There was a little bit of stress during the pre-construction phase to make sure that we could still deliver that project on time and deal with those. So that was an area that we probably could have done better. I think you've heard enough from me. I'm going to sit down now and I'm going to turn the time to Boyd to go talk, discuss some of the structures that were addressed on the project.
Okay, I have 2 minutes. What do I have to? Okay, great. As you heard, this is not a structures project. This is a roadway material hauling project, a rock cutting project, and a Nather Lane project. But we did have a few little structures scattered around. And first one we'll talk about is just off the north end of the project. We found this little 10 by 10 box culvert. You got bridge inspectors don't know about it because it's too small, but we went and were able to find some plans and realized that the head wall of the structure was just outside the limits of the new roadway northbound going up the hill. So we discussed options with structures and also with the region and the project team and said, hey, what's the best way to solve this? We found out that the plans we were able to find were just a scab to the outside of the original box. We never had plans for the original box. And so after going through a number of options, we determined to put a roadway barrier, protect the box in place and move on. And that's what we did with the box at the north end of the project. One fun thing about this project is that we were doing widening to the outside as we've talked. We've had some great big cuts and some great big fills. Especially the south half of the project from the summit down, all the water was running through our project. And so part of the challenge that Tyler and his group had was to track down all the big culverts going underneath the highway and extend them, which was kind of a challenge. I have some big pictures. It's kind of hard to see, but there's a head wall right here on this one, and there's a head wall about there on that one. We worked really closely with Tyler in the layout of the fills and how those fills were going to cut, where they were going to break the slopes, and with their drainage folks to determine what the orientation of those head walls needed to be. I think we only had 2 or 3 that were actually 90-degree head walls with typical flares. All the other ones ended up being at funky angles to match both the side slopes and the orientation of the water. The water did not cross under an I-15 perpendicular. It was always coming through on about a 45 or 60-degree angle. We needed to catch that, redistribute it, keep it in the channels, and keep it going. The contractor did a great job of fitting in those head walls and getting them to work with the surrounding stuff. Tyler mentioned Bull Hollow Road. This was our one crossing through the length of the project. I had to look it up here just a minute ago. Originally, we put this overpass in, we as in UDOT, back in 2003. So 12 years later, we're coming back and we put in this nice big pipe, and we got to make it longer. So as part of this project, we did extend the outside. And so your eyes don't freak out. These pictures are both oriented differently. So this end is this end on this side. One of the challenges we had on this one is the geometric layout of Bull Hollow Road. Bull Hollow Road was going up in elevation to the west. On this side, you can see it going up. And our pipe orientation was also going up. And so we spent some time with some good survey. Kobe Christensen and some of my EITs really looked at that geometry to make sure that we could extend that pipe the limits that we needed to and still keep it buried. If we can't bury a multi-plate pipe, we're in trouble. It's going to buckle and it's not going to work. This is a picture. I'll give Contact credit for this. They took this picture, and this is on the other end of Bull Hollow. And I don't know that you can see it, but one thing that we learned, UDOT does have standards for multi-plate pipe, and then they define the thickness up to a certain diameter. Certainly, if you look really close, you can see a person. That is not a person that's challenged with height. That's one of our contractors right here. So we did have some big head walls going in. One of the things that we discussed in the pre-construction meeting and after is options on how to build these. The contractor had an option that they discussed about putting in a concrete wall and then tying a new pipe to it. We felt strongly after visiting the structures that the best thing to do would be to tie to that existing plate. If you look really close, you can see the steps where the old pipe is and the new pipe was being extended. Going out there today, and I talked with the UDOT bridge inspectors the other day, they did a final construction inspection, and if it wasn't for a little bit of oxidation between the old plate and the new plate, you wouldn't even be able to tell that this had been widened. They did a great job of fitting it up, pulling it together and pulling it out. One of the lessons learned we had on this project is we prepared a situation layout, prepared the reinforcing design for the head walls, but the pipe itself is a supplier designed. Contec did this design, and if you look really close, this picture is supposed to be showing you rebar that's lined up. It's actually shown up here. Part of their design had a thrust beam up near the top of the pipe to help provide stability in its long-term service condition. One of our lessons learned on this project is as we structures folks review those shop drawings, we need to make sure that they're sloping the top of that concrete thrust block so that it sheds water. We don't want to create a pond on top of this pipe with the water coming down from the pavement that's going to cause deterioration on the pipe. This is not a great picture, but the wildlife crossing is actually staged in 2 different locations, and we only have to widen the northbound structure. I say only. This was one of the toughest parts of the project because the wildlife crossing did not cross I-15 at a 90-degree angle. It would have been nice if it had, but it did not. So this was the controlling width for traffic control over the duration of the project. We had to maintain the width that we needed to, and it actually controlled some of our shoulder widths at this location, and then widen the pipe in kind. And so this plate arch was the tightest geometric place in the project. The contractor utilized soil nail walls both at this location and Bull Hollow. Luckily, they didn't follow our layout line. They were able to twist it and fit it to fit the site condition really well, maintain traffic on the existing pipe while they're exposing and building the adjacent pipe. And it turned out really well. As you look inside it, like I said, the only way that we could tell between the old and the new was we had a little bit more glare from the new pipe compared to the old pipe. The alignment was really good. The bolt patterns were good. They did a great job of lining those up. Overall, Ames did a great job on constructing the structures portion of the project. It's a fun project to work on. And it's 2 minutes. I'm going to pass that on to our environmental folks. Thanks.
Okay, I'm Sonia Hootmacher. I'm the lead archaeologist for the project. Some of the lessons that we've learned during the pre-construction phase of this project, just to start, was get your environmental studies done really early. One of the issues on this project is that we had several different phases. Lots of ideas were thrown out during design, the initial design. And we started with getting those surveys done as quickly as possible. That way we could stay on schedule, or as best as we possibly could. This was the first design that we had. It wasn't really a design in terms of what these guys are talking about. This is the first task that we were asked to do by UDOT, was just to go out and re-record some archaeological sites that we already knew were present out there. Then the project was changed to add an S-curve, so that's the purple line there, and then we added the Wildcat interchange, another 100-foot expansion on the east side of northbound I-15, and the first chain-up area, which was on the southbound side of the project. and then another chain-up area, and then another S-curve. So we ended up modifying this project 7 times to include seven different cultural and environmental resources components. Now, just as a heads up, and the reason why I say get this done as quickly and as early as possible is that the other agencies involved in the project, they reset the clock every time a new component starts. So the review time has potential to delay a contract, especially when there are so many different design changes. Sometimes that's necessary, and for the purpose of this project, it was completely justifiable and it needed to be done. It just extended what we had hoped would be maybe a year-long process into almost a 2.5-year-long process. So the most significant environmental resource that we were dealing with along this project were archaeological sites. There were actually 40 archaeological sites identified throughout the project area, 30 of which were eligible for nomination to the National Register of Historic Places. That's a good chunk, and that's also, 25 to 50% of the project area? Now, when we go out and we are designing a project, when I say we, I mean the project team, the way to minimize cost of the project is to design around eligible archaeological resources and other environmental concerns. But that can be kind of challenging. In this case, it actually worked out very well because the project design team was able to design around all but one of those eligible archaeological sites. And the one that was remaining ended up being 3/4 of a mile long and almost half a mile wide. So let's just say it was a big site. It was something that had to be dealt with. Tyler pointed out where roughly where that site was. It's not a complicated process, but it takes time to mitigate an archaeological site of that length and that size, especially when other agencies are involved with the project. And then just understand that those agencies involved have different goals. These are just some of the agencies. We had 2 different BLM offices, SITLA, we had a DNR, the U.S. Geological Survey. We had so many agencies involved for the environmental. That's fine. It's what happens. You know, everybody knows that environmental resources are an issue, and we try to mitigate and reduce those issues. And we were able to do that on this site or on this project, and only ended up having to manage one cultural resource, which was pretty great. The last thing that I'd like to chat with you about a little bit is the communication and cooperation between the team. Because we had so many different phases of the project, it was imperative that we all talked and communicated about those design and concern issues, those changes to the project, so that we could get our environmental teams out early, as quickly as possible, because those clocks get reset, especially for cultural resources. Those 7 different phases involve 7 different modifications, several different field stints to get out into the field, get resources recorded, and get those addressed with the agencies. And we did that, I'd say, pretty successfully, and were able to get feedback, most of which was was like, great job, you're good to go. So we mitigate one site, and we're great to start. So, I mean, I'm quick, I'm easy going here. We'll pass it on to ATMS if they're here.
Just want to step back a second to kind of talk about some of the lessons learned issue. We started off this design process actually about 4 years ago. We decided to go ahead and get some, the environmental done early. We got money set it forward for it. We started environmental. My main designer decided to take another job with UDOT, and so he left. So we hired a second designer. It was a rotational, come on board, doing a great job, and we had Fred Daring show up, and we went through that project, risk analysis. And one of the things they said, what happens if your designer leaves? So that could happen, but we don't think it's going to happen. 2 months later, he left to a private consultant, and we had to go through the process to hire Tyler, so we had 3 designers. ATMS. This picture right here is the first site going northbound. And when we went and looked at this site here for the ATMS, we said to ourselves, here's where we could place this camera right here. We wanted a good view going both northbound and southbound. And I think now, hindsight looking at it, when you're doing ATMS design, you need to think about the built condition. Because when we built it, this ditch was placed in afterwards. And we couldn't place the camera at that location. You can see right here where the ditch is. There's a culvert right in this area right here. And the issue we had, so we had to move it. So we moved it further up the hill. And then we found out, working with our ATMS people, when we have a fixed camera that's on top of the pole, they have to be within 10 feet of the pole to be able to service the camera. We didn't know that, so we had to build access roads. So that's what you see right here is an access road to the camera. And the funny thing happened here during the construction is the contractor brought this during the springtime, which was a wet springtime, plus it was also wet in the area. He brought the concrete truck in here and got it stuck in here. Not one time, but twice. You had to get a hold of Ames to come in, I think it was with one of your dozers, to pull the truck out. So there's also those conditions. So by moving the camera, and even if the camera was in its original position to begin with, we have a NID up here at Wavetronics to count traffic, because part of the concept of this project was to be able to do a variable speed limit like we did on I-80. So we placed NIDs in different locations. The NIDs are good up to 250 feet. Well, after we hindsight went out and looked, from the position of this camera to the southbound lanes on the outside was 415 feet. So this actually only now works for northbound. The other thing we found out too is we had lots of issues. We're still working with issues on the ATMS. Main thing is get somebody on board, knows what they're doing as far as the solar design, and figuring out what has to be built. I think what happened was a contractor came in here, kind of looked at the previous project, started building the pads. You can see the concrete pad right here, and he didn't build it wide enough for the battery box. So the main thing is to make sure you have your design for your solar, for the battery box, so you can go you can place your pad the right size, you can place your pole at the right location, and it's the right size of pole to accommodate the solar panels. All those things we were finding out in this project that are issues that we need to be looking at UDOT. We understand how UDOT's looking at trying to come up with their own standard designs for solar to be state furnished. Another issue we run into, just to have a clean the other day, is on the lids for these the ATMS. We have fiber communications, we have traffic signal, and we have electric signal lids. We're still dealing with those issues. Our specs are not the best when it tries to clarify what needs to happen. So here's just to show you the structure support. Our specs only say right now is that it's supposed to be reviewed the stamp by a structural engineer. They came to us, we said, what are the loads on it? Are you sure it's going to work? Because based on the last project we had issues with it. They had to come back later on and add additional flanges on the pipe. We went back and forth on this. We finally said, well, our guy had accepted it, so we'll let you go ahead with your structures. I had worked with Grant over here on geotechnical to look at the soils. We felt it was undersized, and it was interesting when it came back in installation, they came back larger than what he initially proposed to us. Solar panels. Another issue we have, we're wondering about, because these panels here are very large, but we're just trying to operate one NID and one camera. And look at the size of these solar panels. Again, back to the contractor, I think he went in there based on the past project, and he built the fencing around there, and then he started adding this stuff, and you can see how close the solar panel is to the fence. There was even talk at one time that we had to actually lower the fencing to allow the panels to be placed. So this one actually fits, but to make sure the design is done first, and then build your stuff around it, the fencing. This just shows the distance from that pole to the southbound I-15 over here. It's 415 feet. The NID doesn't work for it. Now with this is another location southbound, working with Utah Power and Light or Rocky Mountain Power. We wanted to place power for this location right here for a camera, Initially, it said it's going to be right here at this last pole. Well, during construction, working with Rocky Mountain Power, said, well, that can't happen because we can't put your transformer on this dead-end line. So we're going to place a new pole because our new standard is to have 40-foot poles. These are 35-foot poles, so we'll have to go out there and put a 40-foot pole in, but we're really busy right now. This throws a lot of frustration in the project with the contractor trying to get his work in. So make sure you coordinate with Rocky Mountain Power and you know exactly where the power is going to come from and you have the right pole, so reduce that frustration. This site right here is at Bull Hollow Crossing. It's an RWIS site. The reason why I show this picture here is to show you, just show what we have right there. It's an RWIS site. Show you some of the components we have. We have the devices here to measure the temperature of the roadway and ice of the roadway. We have weather devices here. We have a similar site on our last project. This is the solar panel used to power that site down there. Look how many panels we have there. We went to my last project, which is just south of here. This is another RWIS site, same equipment, and notice the size of the panel. This panel is 43 inches by like 63 inches. So why in the world do we have a panel this large? So we still have issues within our own design group on how large these panels should be. This is a very, very large and expensive site to power that RWIS, when this one here is working just fine. Another issue we had too, we found out during construction, we had desire to place a camera right here on the southbound lanes inside on top of this little knoll for the best location to be able to see northbound and southbound. When we started talking to our guys who maintain these cameras, we found out something interesting. They cannot park on this side of the road right here and cross the freeway. Our maintenance guys can, but our maintenance guys, our normal maintenance guys out of their sheds, they can cross the road and put their life at risk, but our maintenance guys for cameras cannot do that. And because the project had proposed placing all this barrier here, we had to come up with a different idea. So we moved it down the road to this location. You can see the pole there. So we were able to find a location. It's not bad, but we sold this barrier still extended down here, and actually the plans had shown it to extend even further down the road. We were able to cut it, and actually this is going further than we really needed to go. But we give an idea. So what has to happen now is he had to come up over this hill, the truck does, with his lights on, and he has to back up to this location. Again, we had to provide a pad within 10 to 15 feet so they could access the camera up there. So don't forget the pad, where the truck has to access, what side of the road you're going to be on. Brett?
So I'm going to go into some of the construction lessons learned. I think we've been through a few, but the first one that I wanted to touch on that I think Ames and our inspectors and everybody out on the job did really well was the maintenance of traffic. From what Tyler said, we looked at this extensively in design. They more than me, but the limitations of operations from the region, they were very concerned with this section of road because there is no way around it really. You have to send people up over 89 for a detour if we ever had a problem on this road. So the limitations of operations for the contractor were set based on that. We had 15 limitations, which maybe for Salt Lake is not a lot, but for our area on I-15 seems like quite a few. It was 3 pages of limitations when we usually only have 2 or 3. The contractor did a very good job at these. And with these 15 limitations, there was a fairly big disincentive for non-compliance that was at the engineer's discretion. We never used this once, but just for an example, on Friday through Sunday, if they didn't follow these limitations, we fine them $1,500 every 15 minutes. So it was $6,000 for the first hour, and then thereafter it was $1,000 every 15 minutes, which is fairly a lot of disincentive. I mean, if we're not following these limitations. So from a region standpoint, they put these out that we wanted compliance with them, and we felt that that was a big enough disincentive from the for the contractor that they would follow these. With that being said, some of these we found out in construction weren't possible. When we pulled barrier, and I'll talk about it in a bit, but we pulled some barrier up. We figured that the road had been, Boyd said that it had been done in 2003 when they built the Bull Hollow structure. They had overlaid it then, the road itself. But what they had done, and I'm not sure why they did this, but there was barrier, and then they came in and put 1.5 inches of HMA up against that barrier. So if we ever went in from a UDOT standpoint and put an overlay on that, we'd have to replace all that barrier. So we didn't find this out until construction. They had to pull all those barriers, and we had to pave that through these uphill sections because there was a lot of barrier in these uphill sections. We had to pave that, and you couldn't do it and keep 2 lanes open. So I know we looked at this a lot, but that was one of the lessons learned, that we need to look from a construction standpoint, that we can actually follow the limitations of operations. Ames worked very well with us. They only did it Monday through Thursday. They paved in the day when we had the least amount of traffic. Another operation that we had trouble with was removing paint stripes. How do you keep 2 lanes open when we're removing paint? It's physically impossible unless somebody can tell me how it's done. I don't know how it's done. And from that aspect, they did it at night when the traffic was the least. They worked with us well. We worked with them and said, we're not going to charge a disincentive. You can't physically do it. But on just about every other item, they were able to follow the limitations of operations. And I don't know if any of you went through it, but we never really did have, there was a couple of times we had backup, but on a side project this big, that is very, a job very well done. One other thing that Tyler talked about was the rumble strips and the UHP. I'm just going to go, I don't know if these are all necessarily my feelings, but when we had the post-construction conference, a lot of our maintenance guys, our inspectors, the contractor felt that the rumble strips did alert people, but they weren't, we felt we got more compliance with the UHP, which rumble strips aren't supposed to be for speed anyways, but we got a lot of compliance with people on the speed, and it allowed the traffic to flow good through this project, and tried to protect the best we could the construction workers and the UDOT personnel that were out there. I'd have to give a kudos to Ames for this. This job flowed very well. It's in a climbing area, hill. We never really had, like I said, we had 2 or 3 backups on the job that I'm aware of. And I actually talked to, most of you know Brent Beach, but he's our safety guy for Region 4. He actually told me there were less accidents during construction than there was when the road was normally open. Like every project, we encountered problems. Some of these have been talked about. We had soft spots. A couple of these areas were taken care of in design. We actually knew they were soft. They went in and did a modified pavement section. We fixed those. But then we had a fairly decent amount of soft spot repair on this item, or on this job, and we overran it, I don't know, roughly double. There were a lot of soft spots, and Ames worked well. We tried one thing, we tried another thing. Some places we had to repair 3 times because the soft spot repair that we're doing wasn't working. They were very good to work with us even though they were moving. I don't know if any of you went through the job. When they showed up on the job and they went to move dirt, they moved dirt. We had to keep ahead of them. I mean, that was one of the things that was pushing us. I mean, you saw all the big cuts and stuff that Tyler showed you. This is one of them that I showed you on the side. I think this is the small rock cut that we had, and I think it took about a week to take down, and they were working on other things during that. A couple other things, the pipe and drop inlets that we learned. I think this happens on all jobs, but we had quite a few pipes that we found. I mean, they were able to find all the big pipes. They called them out in the plans, but some of the small pipes were left out. From a maintenance standpoint, we already had some problems with soft spots in these areas. We extended these pipes, and the ones we found and the ones that weren't called out in the plans. But one thing that we learned on these big pipes, they were all at a skew. Some came out about 45, like Tyler said. One of the things we learned in design is they called it out from center to center of pipe. On a skew on that big a pipe, you need about 3 more feet on the far end. So you need to call it based on the longest length of pipe so you can cut it at the skew and put the head wall there. We had to extend, they had to get some more pipe and extend some of these head walls, because from plan, let's say it's 6 feet, when you cut it at a 45 degrees, you lose 3 feet of that pipe. We had to extend a lot of those, and then we had to make sure that the band went on them. So some of those head walls are out farther than what was designed, but that's sort of what we had to do to fit them in. 2 minutes, wow, okay, I better get going. Just another, I think the biggest thing that I wanted to cover with this slide is, like all projects, we encountered problems. The thing that I think was the best with Ames, and I'll have to give the credit to the inspectors out on the job, they solved a lot of these problems, and our field engineer solved a lot of these problems out in the field at the lowest level and as quick as possible, because we had to get these things done. Ames was moving along, and we had to make sure they were done. They made some decisions and were good at quick resolution of our problems. I just wanted to show you some of these. This is the bolt hollow structure that Boyd was talking about. I just wanted to see some pictures. I mean, sometimes structures get a lot of the fame, but this is before construction, the bolt hollow. This is looking west. This is when they started demoing the wall. This is them putting up the, it's a similar picture to what Boyd had. You can see the thrust block right there. But them putting in some of these panels, they had a big crane there, and then putting the foundation in for the head wall. And then this is a finished picture. I should have got one from the other side, but the one that we were looking at before is on that side, but we widened this side and that side. I think the outcomes that we had, as you go through there, you can see that all the materials that they provided or produced met specification and got bonus. I mean, I think from a material standpoint, we got a quality project out there. From the dirt working, the side slopes, they all look really well. We did a lot of dispute at the lowest level possible. A lot of friendships were made, especially between the inspectors and Ames crew that was out there working, which sometimes in construction projects that's not the case. Sometimes they're at a fight, I'd say. On this project they did a lot very well. We were able to maintain public safety. Even with all those overruns, we underran asphalt so far that we stayed within budget. And we did it safe for the traveling public, and we got moving.
Environmental's back. And this time it gets a little more fun. So the first thing that I'd like to start out with environmental is there's 2 phases to construction to a project, pre-construction and construction, right? Well, there's also 2 phases for environmental. Your pre-construction surveys and your data recovery if your project goes into it, especially as it relates to cultural resources. So this caused a little bit of confusion on the contracting side. Desert West was hired to do all the pre-construction surveys. Yay, that's great. That's great news, right? We got all that done. When they said environmental needed to come back and do additional work during construction, contracting, as I understand it, was like, no, 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 they can't do the same tasks again that they were doing during pre-construction. So what we ended up having to do is write out kind of the differences between the work that we were doing, archaeologically specifically, in pre-construction and then in data recovery. This contracting issue delayed us, I'd say, maybe a month, at least a month, and just making sure that everyone understood what the differences between the tasks were. They are completely two separate tasks. And we were able to get that straightened out, but it delayed us getting out into the field. One of the cool parts about this project, I thought, even with the construction or the contract delays, was that once that contract was executed, we were able to turn around a data recovery plan, get it pushed through several agencies, not just UDOT. We were also talking about the BLM and the State Historic Preservation Office and the Public Lands Policy Coordinating Office, as well as a few other agencies that just happened to be involved in less than 30 days. That's amazing, especially when we're doing data recovery on an archaeological site that is 3/4 of a mile long and is on BLM land. And also, this data recovery is happening during construction. So we are out there while we've got track hose peeling away at a wall near where we're working, or installing access roads, or whatever's need to be doing, whatever they needed to be doing in that area. So we were able to get out there and start work. After a little bit of a delay, we had 15 days to get that work done on a 3/4 of a mile long site. So one of the issues that came up during that period of time were these ideas of resource buffers. When we go out and we record an archaeological site, we have anywhere between about a 3-foot and maybe a 10-foot buffer that we usually put on the edge of the boundary, just to make sure that the boundary of the site is protected and that we're including everything. As you can see from this photograph, the construction team also adds another buffer to that when they put up their environmental fence. So I'm going to step away from the mic here and kind of speak loudly. The edge of the archaeological site is actually up where these trees are. And we have this cut, or this blockade, with this environmental fencing, probably 20 feet maybe? Sometimes upwards of about 20 feet below it. It didn't need to be that wide. Basically what we could say is, you can put your environmental fencing way up here. You can go up closer. We just don't want it to actually touch the boundary of the archaeological site. We want to make sure that that's protected. And it also provides a little bit of additional work for everybody to work in, or additional area for people to work in. So the next issue, and this was not really a huge issue, it was just kind of something amusing that we had to deal with, was the terminology differences. This, to an archaeologist, is a decorative retaining wall. To the design team, that's road base. It's not a big deal, it's just kind of something that we found a little funny. The other issue was the weather concerns. I told you a little earlier we had 3/4 of a mile to mitigate, and we had 15 days to do it. And during construction, we ended up having to deal with several different times of weather delays that caused problems for us while we were out in the field. We had rain, we had snow, we had lightning, and we had something that I like to call thunder snow, which is what was happening right here. It was thundering, and it was really sleet snowing. It's something we can work in to a certain degree. We need a little bit of ground visibility in order to work. But it causes, on this particular archaeological site, it was very muddy. So I actually fell backwards into a trench that we had excavated just because it was slippery. Nobody got hurt or anything like that. It was just, the rain and the snow can cause some problems while we're out there doing field work. The next issue was wildlife nesting, and I got photos last night, but I wasn't able to throw them in here this morning. There was a turkey out there. Now, turkeys are not sensitive, threatened, or endangered species, but she was nesting. There were 12 to 13 eggs in her nest, and we didn't even know she was there. She was actually camped out right in a culvert right underneath right below one of our archaeological sites. And it was actually that site that I showed you with the retaining wall / road base stuff. Someone actually walked up and stepped on her, and she squawked at them. And everyone's thinking, ooh, dinner. Well, we ended up calling DNR, and they said, hey, the best thing to do is just to wait until those chicks hatch, and then they get out of there, and everything's great. So that caused a little bit of a delay. It was, 2 weeks, 12 to 14 days, I think, to get that, to kind of wait that out. So we had to redirect the contractor to move to another area to work. So wildlife. It's not just archaeology causing problems, it's also the wildlife on occasion. In this case, just a turkey, who's probably going to be dinner here soon. That's the hope. And of course, agency requirements. I want to show you a picture here. This is one, we call it a 10 meter by 10 meter test unit. We're doing what's called a surface survey. Big sigh. One agency's goal is not always the goal of the project proponent. For this project, it was mostly highway safety, and some improvements, but the BLM in this case is more interested in getting the science at the archaeological site. Remember I said 3/4 of a mile long and almost a quarter to a half a mile wide in some areas? They wanted an entire surface survey of the artifacts at the ground surface. We are talking thousands upon thousands of archaeological little flakes of volcanic glass and chert and quartzite that we are doing analysis on. It takes a lot of time. And the BLM's not paying for this project. The state is, and the feds are. So the BLM's getting an awful lot of information out of this archaeological site at the cost of the project. So looking back on this sort of thing, if we had had more time with the contract delay issue and the preparation of that data recovery plan, I probably would have pushed back a little bit more and said, look, the only thing that's going to be affected on this particular site is the area between the road cut and the right-of-way fence. Those are the areas of concern. We can do some selective sampling on the other side of the fence so that you get your scientific data, but the issue is between the road cut and the fence line. That's what we need to focus on. And the problem was just scheduling, timing, because of contracting and because we needed to get the work done. We had to kind of compromise on that, and this is still something that we were dealing with. We were actually out in the field this last Sunday. So we were out 5 days this last week trying to get all this work done. There's still 10 more 10 by 10 meter units to sample up there. I finally overruled the 100% surface survey issue and just said, no, we're going to sample this last bit. I just had to make a decision in order to make sure that we could finish our project for UDOT on schedule. 1 minute, which is great because the last, of course, is, again, that frequent communication is imperative on a project like this. We were able to work with the construction team, I think, very successfully. You guys were talking about friendships a little bit earlier. We had some great relationships. My entire team enjoyed working with this team. And I think that's fantastic because many times environmental is seen kind of as the enemy on a project like this. We're part of your team. We want your project to succeed. It's our project too. We don't want to stand in the way. So we communicate, we get things done, everything finished successfully. So thanks.
Okay, my name is Brad Soleric with Ames Construction. I was the project engineer on the Pine Creek Climbing Lanes project. I'd like to give you a quick overview of some of the construction items on the project. We moved 500,000 cubic yards of dirt. 60,000 cubic yards of that was classified as rock. We crushed and placed 250,000 tons of aggregate for the roadway profile, extended approximately 35 culverts. The paving consisted of 59,000 tons of HMA at a thickness of 8.5 inches and 12,000 tons of stone matrix asphalt at a thickness of 1.5 inches. After the asphalt paving was done, the project for 7 miles in each direction was covered with microsurface from edge of pavement to edge of pavement. We also installed a new climbing chain-up area at the Sulphurdale southbound on-ramp, including signage and weather event warning beacons. One of the most important activities performed on the project was the partnering between Ames and UDOT. Construction phasing and strong partnering allowed us to improve costs and accelerate the schedule. Partnering between UDOT and Ames provided quick resolution to unplanned construction impacts, efficient planning of time and MOT resources, allowed for additional acceleration to the schedule, and effective partnering enabled project flexibility for additional scope of work. This was been addressed by Sonia and Brett regarding the work that needed to be done to clear an area for additional work. Moving on, I have 3 aspects of the project I wanted to discuss. I think we've covered quite a bit of them. I'll try not to repeat too much. The multi-plate, just some quick data. 2 elliptical multi-plates and 1 arch. We extended them approximately, the elliptical multi-plates, 30 feet each, and they were 37 feet wide and 25 feet high. The arch we extended 38 feet and was 27 feet wide and 13 feet tall. This picture was the first step in the construction phase, was to install the soil nail wall. You can see we were working in tight conditions. Our subcontractor needed to bring in a specialized, smaller piece of equipment to perform installing these soil nails above the existing multi-plate without damaging it. This is after the soil nail wall's been installed, and we've dug some of the foundation and started to install the plates, more of the installation. And here we've seen this picture in different forms before. The multi-plate's been extended, and the cantilever head wall foundation is being installed and being ready to pour. This is when the walls are going up. This is one of the first times we started encountering groundwater on the project. The installation of the multi-plates took place in the late spring, and after the rain events, a day or 2 after, we had sealed quite a bit of groundwater seeping through the roadway profile and into our work areas. We needed to pump, obviously, while we were working there, and then we also installed a permanent French drainage system to remove the water from behind the wall. And here you see the walls being stripped and the completed and backfilled exposed head wall. Soft spots during construction. We've discussed this a little bit. This first picture on the left, after we removed the existing pavement we would, in certain locations, we would see groundwater just seeping out of the roadway profile and puddling up along the face of our excavation. Encountered the same thing after heavy rains. We'd have healed up a soft spot, and you know, a day after a heavy rain, see the groundwater seeping through there again. One idea for subsequent projects, we talked a little bit about geotechnical exploration. It would be advantageous to do that geotechnical excavation during the projected months of construction. That way, both the client and the contractors bidding the project know what they're going to be getting into during that construction time. MOT, we discussed MOT. The goal of the project was first and foremost safety of the contractor, the client, and the traveling public. We took that into consideration before any work activities were performed. Accomplished work without impeding traffic. We needed to schedule work during peak capacity flows, weekends and holidays, such that the public was not impacted, and complete the construction in one season. We were in a rural highway setting. We had 80 miles per hour posted in both directions leading up to the project, so the traffic was accustomed to you know, pretty much moving along as fast as they could. Approximately 20,000 vehicles a day during the construction season. We had late spring snow events and summer recreational vehicle traffic to plan around. And well, there was another a photo here of this accident. The photo below it shows a completely bald tire traveling through our project during a late spring snow event. So on a day like that, you know, we understand the conditions on the road, so we just shut the project down to keep our workers safe. Okay, well, I appreciate the opportunity to come up here and got a little bit about temporary portable rumble strips, but we've already discussed that. So, thank you.
Just wanted to real quick talk about some ATMS construction issues. Initially, design, again, one thing we want to emphasize is going out to make sure that you look at the plans for your ATMS on site. The camera was planned to be somewhere down along in here. We initially had a camera up, one of those live view cameras up on this hill up here, and we told maintenance that we would put a new camera there, and at least to be able to have the same camera view. Well, we had to move it. The other thing too that happened is a vision I had was not to make the embankments any higher. The initial embankment went like across there like that. You can kind of see from that point to that point. But during construction, more material was piled up on top of this hill. In fact, it was even higher than that. We got the contractor to come back and lower it. So we placed the pole and all our stuff up there. Again, we have another access road up in here. So you can see from this photo here, we have a good view, both directions, so it worked out okay. This is a photo we had here. The problem we're running into now is too far across. We can't catch the southbound lanes with our Wavetronics. So always keep that in mind is where are you placing this, how far is it, what's the purpose of it. Another item we had Wanko sign was existing in the project. We had power brought to, it was a solar project and a solar powered Wanko sign. We decided to add power, but the problem was we keep in mind is that there's clear zone issues still. It was placed somewhere in here. We had to do a change order to move the power supply back further. And I know on another project we had, this is the conduit going to the Wanko sign, that there was a design I've seen before where you had like breakaways down here in case the pole got hit that would sever the connection right there. So keep those in mind when it comes to that. So what we try to do is here is appreciate everybody for participation. We're going to open for questions here in a second. What I've been doing is gathering lessons learned as a Word document. If anybody has a desire to get the copy of that, just give me your card or your email address, and that way then I can, as I compile everything together, we can send it out, the lessons that we learned from this project. Are there any questions you'd like to ask anybody of the group here? Arthur.
What specific archaeological resources were there?
What specific archaeological resources were found? We had quite a few prehistoric archaeological sites ranging anywhere between what we call the Paleo-Indian period, which is 12,000 years old, to late prehistoric, which is just before Euro-American contact. So it's very rare to actually have a Paleo-Indian site. It was actually located very near to where we were working. And that site was able to be avoided, which was fantastic because they're very rare and highly valuable scientifically and culturally. We also had a few historical archaeological sites. I mentioned earlier that we found 40 archaeological sites, 30 of which were eligible. Almost all of those 30 archaeological sites were prehistoric. There were just a few that weren't, specifically the historical road, and maybe, I think it was mostly roads and trails that were the historical eligible sites. So, not sure if I answered your question, but lots and lots and lots of flake stone. It's quite common in that area because there are old volcanoes that provided those lava flows and those basalt flows. So.
Any other questions?
Obviously, for these remote locations, you were able to use solar panels for power, but what mode of communications did you use in these areas?
Fiber.
Did you use the UDOT?
So going back to one of the things we need to work on our own standards is that these cabinets are being used for all these locations where our standard 334 ATMS cabinet. I was on site with one of our technical guys, Greg Ogden. We opened the cabinet going, why do we have ramp metering equipment in this cabinet? We'll never meter any kind of ramps out here. So we need to look at that and come up with a design for solar so we're not paying for equipment we'll never use. Any other questions?
Troy, did you stripe it so the truck climbing lane was added to the inside or to the outside, and how did you decide which way to do that?
I think the truck climbing lane, if I remember right, Brett, is to the outside. What, Ryan, is it the outside? It's to the outside. Truck climbing lane.
Just based upon impacts, we didn't consider having to be some areas where there wasn't enough room to widen the sidewalk wall. So to the outside,
Any other questions? Well, thank you for coming. And so if you want a list of all lessons learned, I'm compiling from each area. My contact information is right here. Drop a card off with me and I'll get it to you. Thank you again.